Hi students, today we are going to discuss about design thinking concept in vector calculus. In this 3D dimensional space involving magnitude and direction. So in this magnitude and directions we are going to represent vector calculus. Okay, so through design thinking. So what are the 5 stages in design thinking? Anyone tell what are the 5 stages?
The 5 stages of DT are empathy, define, ideate, prototype, test.
So these are the 5 stages. So first one is empathy, second one is define, third one is ideate, and fourth one is prototype. Next fifth stage is testing. So first Satyasri, tell about empathy part one.
Engineer faces many challenges such as sudden change in direction, variation in speed, and maintaining the proper motions. Without a proper mathematical analysis, controlling these systems becomes difficult. So engineers need these tools to correct these things. So this real-time need let us know about the vector calculus.
So the main purpose of empathy part is
To know about the customer's needs.
need. Okay. So the next one is, what is the next stage? Definition.
The defined problem is how can we mathematically analyze and control the motion in three-dimensional space. Basically, scalar mathematics is insufficient.
So scalar mathematics insufficient. Okay. So what is the scalar quantity? So in this scalar quantity only magnitude.
Because motion has also has direction, so scalar quantity is insufficient. Vector quantity.
So vector quantity including
Magnitude
magnitude
and
and
direction.
directions.
So vector quantity represents. So the problem requires vector representation. Thus, vector calculus becomes the ideal solution.
Okay. So the next stage is ideate.
The vector calculus helps us to understand the direction and motions of the motions in a simple way. It gives us vector direction and direction analysis and motion vector. When we differentiate vector with respect to time, we can calculate the velocity and acceleration. When this tells us how motion changes continuously. By this, engineers can accurately and on a proper way they can make a model of a machine and many more applications.
So anyone tell about the divergence curve? What is divergence? Divergence it is a dot product or cross product.
It's a dot
product. So in this del dot f vector. So here del denote the gradient. Okay. So here the f vector is a functions of x, y, z in here including I vector, j vector and k vector. So next one is curl is a cross product. So in this cross product the curl is denoted.
When it is 0, it is denoted as solenoid, and when it is non-zero, it is known as irrotation.
Curl denotes del cross F vector.
Divergence denote
Del dot F vector.
The divergence is 0, it is solenoidal, and if the curve is 0, it is said to be irrotational.
Irrotational. So if it is irrotational, it is a cross product that is equal to 0. Okay. So
This idea represents the motion by vector functions of time. Important vectors are velocity vector, position vector, acceleration vector. Vector differential helps engineer to predict the future motion and control system efficiently. This gives us a conceptual solution.
Coming to the point of prototype, in real life we are doing the projects, but in project we are explaining as one of the model. In the model there are many types like divergence, curl, and solenoids. In this topic, in this prototype, we are going to see the models of the three. First one, physical appearances. In this physics of engineering of this physics, first thing we are going to see that work is equal to F into D, and the electric potential and electric dipole, then etc. In that next we are going to see about the automation and the machine learning. In that we are using in the prototype like calculating the numerical appearances, next etc. In next we are going to see the prototype. What is prototype? Prototype gives that objects 3D objects view models. It will help to rectify the mistakes of the project's real models. There are many types of prototype model we can do in before the real projects. And next we go on to the testing.
So this
So
one is
coming to the testing part, the vector calculus model was tested using real-time applications and simulations. So during testing, the vector calculations were used to understand movement and direction. The results were smooth control, better motion, and the results were correct. So this proves that it helps in solving real-time engineering problems.
we conclude that design thinking in vector calculus, we transform mathematical ideas into meaningful and engineering practical